What is a black hole? There are three types of black holes categorized based on their mass and size, being primordial, stellar, and supermassive black holes. When most people think of a black hole, they imagine it to be huge, but in reality, black holes come in a great variety of sizes. The smallest of the three types, a primordial black hole, is believed to be as small as a single atom and at times the mass of an entire mountain. On the other hand, supermassive black holes have masses that are millions or even billions as much as our sun and are larger than the solar system. But how are these black holes formed?
The leading science is that a black hole is most often a collapsed star that is so dense that not even light can escape from it. Stars like our sun don't have enough mass to turn into black holes, but instead, after the sun has consumed all of its hydrogen for fuel, the core will implode and form a white dwarf. But for stars with far more mass than our sun, the intense heat and pressure allows the core to form heavier elements like iron. Unlike the other elements produced before, such as hydrogen, helium, carbon, neon, oxygen, and silicon, iron does not produce any energy when formed. And so as iron begins to build in the core, there is a significant increase in mass without any additional energy added to support the star's temperature, until BAM! The star collapses and implodes into a supernova. This produces either a neutron star or, if the star has enough mass, a black hole. These black holes can then grow in size through the accumulation of matter or from merging with another black hole.
Now we know how black holes got there, but what do they look like? That's a bit of a problem. The gravity surrounding a black hole is so strong that no light can escape from it. This is because of the infinite redshift of light that results from the immense gravity created by black holes. So, when we look at a black hole, we see nothing. The point where light can no longer escape the black hole's gravitational pull is called the event horizon. And if light, the fastest thing in the universe, cannot escape, neither can anything else. The event horizon is a boundary of space-time in which nothing that passes it can affect an outside observer and nothing may return from.
Thanks, guys. Now that we know what black holes are, let's talk about some of the cool things we could theoretically see if we fell into a black hole and why it would be impossible to survive the journey. First, let's talk about why you physically cannot survive entering a black hole. Just like the way the moon affects our oceans to create low and high tides by the perpendicular compression and parallel stretching of the water on Earth, the tidal forces from black holes actually horizontally compress and vertically stretch matter in an ever-increasing way as you get closer and closer to the singularity, in a process called spaghettification. You would actually be stretched and compressed until your body actually looked like a long noodle.
One interesting fact about these tidal forces is that the larger the black hole's mass, the weaker the tidal forces of the black hole are. Encountering a small black hole, only a few times the mass of our sun, would kill you before you even reach the event horizon. But if we could imagine a billion solar mass black hole, you would actually be able to survive crossing the event horizon. This would allow you to see some very cool things that we'll talk about in a minute. Unfortunately, after you cross the event horizon, you have just sealed your fate to never escape the black hole. As you are drawn closer to the singularity, the tidal forces become so intense that your body would be ripped apart until it was separated into individual cells, then to the atoms that make up the cells, then into the neutrons, protons, and electrons that make up the atoms, then into the quarks and other constituent particles that make up them. After this, we do not know what happens because we do not understand quantum gravity.
Now let's get to the cool stuff that you would be able to see if you could survive falling into the black hole's event horizon. Just outside of the event horizon, there's a region called the photon sphere where gravity is strong enough to force photons into orbits around the black hole. This would mean that if you could somehow stop right at the photon sphere and look directly in front of you, you would be looking at the back of your own head. If you were to keep going even further and then somehow stop at the event horizon and look back at the universe, you'd observe an infinite relativistic blue shift, and you'd be able to see the entire history of the universe in a single moment. However, the light would be so blue shifted and therefore so energetic that it would completely burn you into a crisp. Luckily, I don't think anybody will be coming into contact with a black hole anytime soon, so you don't have to worry. Thanks for tuning into the Black Hole Show. See you next time.